Example 15 is giving us general bits of information, and we're going to have to figure out how do we find the values, how do we figure out what the equation is based on certain things. So it's kind of going backwards and using what we know to kind of help solve for things. So we have an equation which is y equals a times the sine of x over b plus c. So each of these different items, each of these different parameters, a, b, and c do different things. So a really affects the amplitude. B kind of affects the period. And c affects the max and min. Or like you want to call it more something like the vertical shift. So it's important that we can figure out these different things. And so what we're going to use is different pieces of information to figure these things out. So, so it shows us a graph, and now just use this. This is just general, right? We don't want to necessarily use all of that, but the first thing it says is, hey, okay, so we've got 3 points. Our points are going to be negative pi and negative 5. We have 0 and negative 2. And we also have pi and 1. Okay, so we start off, and we want to know a couple of pieces of info about these things first. So if we can zero anything out, that would be the best thing to do. So think about back when we tried to zero things out. So a obviously won't be 0. A has to be some sort of value, or else the whole function wouldn't even exist to begin with. So we can't deal with that. If we zero x out, though, we can zero this entire function. Well, why is that? Well, the sine of 0 is 0. So if we know that x is 0, it zeroes this whole section. So that's the first piece of info. So because we have the point 0, negative 2, we know from this, bad one, we know that negative 2 is going to equal a times the sine of 0 over b plus c. Well, as I said before, the sine of 0 is 0. This zeroes the whole thing out. So we know that c is going to equal negative 2 just from that alone. So that's helpful information for us. So now what we're going to try to figure out is extra things for us. So now we can look and say, okay, well, hey, that point at pi and that point at negative pi, those are maxes and mins. So I can use that to help me out. So if I know that my max is at pi and 1, and my min is at negative pi and 5, I can figure out what my amplitude is, right? So amplitude equals the max minus the min over 2. Well, the maximum is 5, my minimum is 1, and I have my max should be max minus my min over 2. My minimum is at it's not. Oh, it's negative 5. Excuse me. My max is 1. I'm sorry. My min is negative 5, and so I get 6 halves or 3. So a can be written as 3. So this is another good piece of information that I needed to know. Now, from that, what I can figure out is that because this is a periodic function, normally I look at the difference between, look at how far does it go from max to max. But what I could also do is think about, well, what about from min to max? That will be repeated again to go back to the other max. So if I can figure out this distance here, I can help figure out what my period is going to be. So the period of my graph is going to be double the distance from my max to my min. So now this is the distance. This isn't the values of my max and min, but the distance between them. So here I'm at negative pi. Here I'm at regular pi. So this would be pi minus negative pi. So that distance right there makes, this is 2 times 2 pi, or 4 pi altogether. Now, that's what my period equals. So normally, you say your period is going to be the normal, it's normally the, your normal period is going to be 2 pi divided by some value b, which this b is normally what's multiplying by something else. It's normally where if it would be in terms of bx. So in this case, because we're dividing by b, we think of this as b times 2 pi. So in this case, we have a period of 4 pi, and if that equals b times 2 pi, we know that b is going to be 2. Okay, so all in all, what we have is based off of the information that we saw from our graph and that we could gather, that this equation actually looks like the following. Well, a is 3, so this is 3 times the sine of x over 2, or 1/2 x, plus negative 2, which I'll just call minus 2. Okay, so you can figure out these functions based off of certain traits that they have. So it's good to get used to thinking and understanding different parts of it, and how we can put those together. Now, the second part says sketch the absolute value of this graph from negative 2 pi to 2 pi. So the absolute value. So the absolute value of 3 sine of x over 2 minus 2. Oops, no, minus 2 is inside. So this is interesting. This is an interesting function. So how do I graph the absolute value of this thing now? Well, we can use what we know about our last function. So let's go look. So before, imagine here that if we were graphing the absolute value of this, and this is that, we are going to take every point, all right, that is below the x-axis and reflect it above. So instead of this being negative 2, we're going to have this up at 2. So you can kind of see that this would bounce back like this. And then we're going to continue going up all the way to 5 and back down. So you can see that this is what that graph is going to look like. So let me go back down here. And so let's say at 0, okay, at a value of 0. So where did they want me to graph it? This is from negative 2 pi to 2 pi. So this is a mistake. Excuse me. So we got 0. We've got negative 2 pi. We've got 2 pi. So let's think about these values for a second real quick. So these are, let's think about our big places here. So this is negative pi and pi. So if I were to, let's say, just input these places right now, I could figure out a good deal of what I am looking for. So if I plugged in 0, the sine of 0 we already determined was 0. 0 minus 2 makes -2, and the absolute value of that would make 2. Now, the sine of pi is, we take pi, plug it in, the sine of pi over 2 is 1. Okay, well, 1 times 3 is 3, minus 2 is 1. So we actually come back and we get this value. The sine of 2 pi divided by 2 would be the sine of pi, which is 0. 0 minus 2, so we go back up to 2 again. And if we have negative pi over 2, this would be -1. 3 times -1 makes -3. -3 minus 2 is -5. This actually jumps all the way up to 5. 1, 2, 3, 4, 5. So like our function jumps up way up here. And then we have at -2 pi, this would be the sine of negative pi, which is 0 minus 2 gives me back to 2. So these can be figured out if you think of these big points. Now, what we looked at earlier, we're hitting 0 here, kind of in an odd spot. So, but we can predict this graph based on what we knew before. So this is a rough sketch, but it's very odd and very interesting how this graph works in comparison to what it usually looked like at the top. So just understand again that the absolute value cannot yield a negative answer. It has to be positive. So you reflect the same image over the x-axis if you know what the original function looks like. So even though it's a little sloppy, you get the idea of what this function is going to look like.